Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we're about to solve is the one that you will find on page number 286. Page 286, and today is our lesson number 176. The problem number 129 is what we are about to solve. In problem 129, we are told that in the xy plane, we have a region R that consists of all the points xy such that 2x plus 3y is less than or equal to 6. This is a condition we have to meet. Or the region is defined as everything, all the points whose coordinates 2 times x plus 3 times y is less than or equal to 6. The question simply is, some point that they're giving us, R else, is that point something that lies in the region? Let's see what they tell us about the point itself. We have to know obviously something about the point, but before we worry about that, let's first find out what region it is that they're talking about. And the simplest and the quickest way, easiest way to take care of that is to start out with a straight line. Forget about this less than or equal to sign. We start out with a straight line here. Let's call it line L. What does it look like? Here, when x is equal to 0, 3y is equal to 6, because this drops out. 3y is equal to 6, which means y is equal to 2, which means we are looking at 0, 2. So if you were to draw it, 0, 2, x is 0, y is 2, which means the y-intercept is 2, 1 and 2. Let's put it right here. That's 1 point, that's our y-intercept. Similarly, when y is 0, when y is 0, 2x equals 6. When y is 0, this is going to drop out and 2x will end up being equal to 6, which tells us that x is equal to 3. So we're looking at now x is equal to 3, y is equal to 0, that's our x-intercept. 1, 2, 3, right here. The line that we're talking about is this line right here. Let's join it. That's our point, that's our line L. Now what we have to decide is the region that they're talking about, is that the region that falls below the line, or that's something that falls above it? So how do we find it out? Or the simplest way to figure it out, how to figure out which region they're talking about, the one above the line or one below the line. I'm going to erase all of this thing, we don't need any of this thing, we got our line. The simplest thing is to pick any point. The simplest thing is to pick any point in this region here, or that region for that matter. Pick one point and ask yourself, is that something that satisfies this condition? And if the answer is yes, then that's the region. For example, the easiest point to talk about would be the origin. At origin here, we are told that 2x plus 3y has to be less than or equal to 6. At the origin here, x is 0, and so is y. And therefore this whole thing is equal to 0, which in fact is less than or equal to 6. Which in fact is less than 6. On the other hand, if they had told us that 2x plus 3y had to be greater than 6, if they had told us that 2x plus 3y was something greater than or equal to 6, then we would have gotten a 0 here, and 0 of course is not greater than 6. That tells us that we're not talking about this region, we're talking about the region above it. Because we picked a point here and it doesn't work out. 0 is not greater than 6. But here we are told that this quantity actually is less than 6. And since this quantity here, when we pick one point here, 0, 0, comes out to be 0, which in fact is less than 6, then this is the region we're talking about. But we didn't have to pick origin. We could have picked any point. For example, we could have picked. We can clearly see that 1, 1. We can clearly see by visual inspection that 1, 1 lies in this region. We could have picked 1, 1 to show here. 2 times 1 is 2, and 3 times 1 is 3. 2 plus 3 is 5, and again 5 is less than or equal to 6. As you can clearly see, this is the region we're talking about. So now we know our region. Let's start our work. Let's see what they tell us in the first statement. In the first statement they tell us that this point that they're talking about satisfies this condition. They tell us that 3r plus 2s equals 6. Well, that's an equation of a line. So what they're telling us is that this so-called point they're talking about, they're telling us what they're telling us here is that at some point, it could be any point. They're telling us it could be any point on this given line. We have to find that line. Very simple, very straightforward process. Same exact process as before. We find the intercept and we draw the line. So here, when r is equal to 0, we'll have 2s equal to 6, which means s is equal to 3. So when r is 0, s is 3. When x coordinate is 0, y is 3, somewhere here. That's the first point. Similarly, when s is 0, 3r equals 6. 3r equals 6, which means r is equal to 2. So when s is 0, s which is the y coordinate, r is the x coordinate, so here we have 2 and 0. 2 and 0, 2 and 0 right here. And it turns out, I'm going to erase this point here because otherwise it's going to cause confusion. This point has no significance. I was just trying to show you that 1, 1 also lies in the region. So we are looking at this line right here. Let's call it line M. Let's call this guy line M. Let's put it in a different color. I should have drawn it in a different color if I had the foresight. It would be easier to see. Here is that line. The question is, here's the question. The question is, do the points on these line, do the points on line M, this is the same as saying, when they tell you, is RS in the region R, is this point RS in the region R, this is same as asking, do the points on line M lie within the region R? To which the answer is, it depends. If you're talking about these points, yes, they do all lie within the region R, as you can clearly see. But if you're talking about the points above the point of intersection, this is the point of intersection right here. If you're talking about any of these points, as we can clearly see, do not lie within the region R. So some of the points on the line M lie within the region, some of the points on the line M above the point of intersection do not lie within the region. So how can we answer it? How can we answer this question? Is the point RS within the region? To which our answer would be sometimes and sometimes not. The first statement is not the first statement does not provide us sufficient information for us to be able to give a definitive yes or a no. Our job always is to ascertain if we have enough data sufficiency. If we have enough data to give a definitive answer, either in affirmative or negative. We cannot say a definite yes or a no. Sometimes these points lie within the region on the point line M, and sometimes they don't. The first statement is not sufficient. Because the first statement by itself turned out to be not sufficient, now we know that answer A, D, B, C, E. Now we know that the answer, whatever it is, cannot be A or D. It would have to be either B, C, or E. Let's look at second statement, shall we? I need to erase a lot of stuff here. I need to erase actually everything, because if I leave anything on the blackboard, it's going to confuse the hell out of us. You cannot intermingle the information from one statement and the other statement. That's a no-no. You have to erase your memory. Two statements have to be analyzed completely independently. So then that's it. We're done with the first statement. And as I always remind you, I don't know why I see the need to always remind you, because I repeat the same exact thing like a parrot. That is something I cannot help. As I always remind you, when we do these problems here on the blackboard, you and I together, we do it in a very leisurely way, because we're doing it for learning purposes. Nobody's timing us here, okay? So don't freak out. Just understand the concept so that next time when you have to do it on your own, you can do it with speed and accuracy. The second statement tells us this. The second statement tells us that r is less than or equal to 3 and s is less than or equal to 2. So again, to start out with, we have to have our original line here, otherwise we cannot do anything with it. We have to have our region in front of us. So when x is 0, 3y equals 6, which means y is equal to 2. When x is 0, y is 2, 1, 2, that's right here. And then when y is 0, this thing is going to drop out and 2x equals 6, which means x equals 3. 1, 2, 3. You see, that only takes few seconds. That only takes a few seconds to figure it out. And then if you look at the point of origin, that's 0, 0, and this whole thing will be 0. 0 is less than 6, which is true, which means the reason that we're talking about, the region that we're dealing with, is this one. Now we're going to tackle this part, okay? We're going to do it in different colors to see what happens. Now the boundary that they're defining here, they're telling us that this r so-called, whatever it is either less than or equal to 3. Less than or equal to 3 is right here. 1, 2, 3. So they're defining here as right here. In the entire line here, anything that falls to the right of it, x coordinate is either less than or equal to 3 right here. Then they tell you the y coordinate, which is less than or equal to 2. They're telling us that this point is such that its y coordinate is either 2 or something less than 2, which is going to be right here. Does that provide enough information for us to know if a point r, which is enclosed within this region here, so that y coordinate is less than 2 and the x coordinate, oh, it's a different color, x coordinate is less than 3, is that enough for us to know if any given point taken at random is going to fall within this original region? The answer is no. Everything else is okay here. See, this is how it's defined here. Everything else is okay here. This part right here, this part is okay, this part is okay, right here is okay, but the problem area is this part. All of these points meet the conditions that r is less than 3 and s is less than 2, and yet they lie outside the region. Our region is this right here. This is our line L, if you remember. This is our line L, and this is our original region. And all of these points lie outside it. These are no good. These points are all outside it. Again, we have the same problem. Some of the points lie within the region and some of the points do not. The second statement by itself is also not good, which means answer cannot be B. This is a nasty one. I know that. This is a very nasty problem. Yes. Let's put them together, shall we? Let's put the two statements together and let's see if we can somehow figure out what's going on here. This is going to take a while. I'm telling you right now. If you want to understand this question, it's going to take a while. Of course, I could very easily stand here and just quote unquote solve the problem in a hurry and be done with it. But we're not here to solve the problem. We are here to learn the material. There is a difference there. If you simply want to watch the solutions, there are quite a few videos on the YouTube, obviously, where people just stand there and solve one problem after another. That is not what we do here. Let's put them together. So, I'm going to remove this marker, it's dying. I should do it someplace where I have enough room. Okay, but again, I don't remember, so I have to do it again because I don't memorize it. So we have to do it again from scratch, and you will see that it only takes a few seconds. Of course, you won't have to keep redoing it because you don't have a piece of paper, you don't have to erase everything. When x is 0, 3y equals 6, which means y equals 2. 1, 2. And similarly here we had 1, 2, and 3. This was our line L. Let's not put line L here right now. Let's do something. Let's do something else. Let's not worry about line L right now. I changed my mind. Let's see what they first tell us in the two statement. In the first statement they told us that 3r plus 2s equals 6. 3r plus 2s equals 6. Again, when r is 0, 2s equals 6, which means s equals 3, which means y coordinate is 3 right here. And the x coordinate was 2. This was our line M. This is not the original line. This is not the line L. This is what we define as line L. This is line M. This came from the first statement. As I said, line L. As I said, we'll worry about line N right here. As I said, we will worry about the line L at the end. Let's first look at the two statements individually. Okay. The second statement told us that r coordinate, the x coordinate of the point that you're talking about, has to be less than 3 or equal to 3, and the y coordinate has to be less than or equal to 2. Let's put that here. Watch what happens. Okay. Just watch what happens. R is less than or equal to 3, which is defined as this guy, and S is less than or equal to 2, which is defined as, oh, plastic. That was the x coordinate, wasn't it? Jeez. Damn it. R is less than 3, 1, 2, 3, that was right here. And S is less than or equal to 2, which is right here. Okay, watch what happens. Okay, now pay very close attention. Now we're going to put in our, I wish I had another color right here, blue one, hopefully. Now we're going to put in our original line, line L. Line L, if you recall, went from here, from 3 to 2. Watch what happens as we put it in. And this was our region. Watch what happens. Pay attention. Pay very close attention. This is our region. This is our region. And as you can see, everything that falls within the constraint that they give us, which is r is less than or equal to 3, which is the right here. So the boundary that they're defining here, r is less than or equal to 3, is right here. Y is the 2 here, right here, and the points, our region is this part here. When you put this along with the fact that M has to be here, along with M and these two lines here, along with the first statement and the second statement, the region that they're defining is this guy right here. Watch. How can I show it to you? I'm going to put dots so you can see it. This is the region they're defining here. This comes from statement 1 and statement 2. Do you see a problem? The problem is this guy right here. I'm going to color it. This triangle right here. All of the points in that triangle do not lie within our region. That tiny bit of triangle is what makes this answer to be E. Even putting the two constraints together does not enable us to tell for sure if all the points that obey these two constraints lie within that region. The points that fall in that region do not lie in our region. Now what I'm going to do now, I know we are spending a lot of time on it, but what I'm going to do now is actually give you a couple of examples so you can see for yourself what these points are. I'm not going to raise anything, we're going to leave it there, and I'm going to show it to you. Watch what happens. Okay, I need to raise it. We're going to pick 2 points. We're going to pick 2 points here. Let's pick 2 points. For example, I can see here, I see a 2 here, 1 and 2. Right here, there is a 2 here. You can see, right there. This is 2. This is 2, y is 2, and x, as you come down, this looks like here. If you eyeball it, it's not half, it's about 2/3. Now if you're not sure about it, and if you put in half, what happens? If you put in 2/3 and 2, again, 1 and 2, so this is 2. If you come down right now, this was 1, so this is about a 2/3. If you put down 2/3, watch what happens. 3 times this comes from the constraint from the first statement. 3r plus 2s has to equal 6. It has to equal 6. It must obey that constraint. 3 times r, which is 2 over 3, plus 2 times 2. 3 cancels out, and 2 times 2 is 4. 4 plus 2 is 6, and it obeys. You see, this obeys. So this point obeys the constraint. X coordinate is less than 3 right here. The y coordinate is less than or equal to 2. It follows the second condition. It follows the first condition. This was the first condition. The second condition is that, what was the second condition? I should have. The second condition is that r has to be less than or equal to 3 and s has to be less than or equal to 2. As you can see, it clearly obeys both of these conditions. It obeys the first condition, it is equal to 6 right here. It obeys the second condition, the x coordinate is less than 3, which is 2/3, y coordinate is less than or equal to 2. But watch what happens. Does it follow this constraint? Does it follow in that region? Does that fall in that region? 2 times x plus 3 times y. 2 times x is 2/3, plus 3 times y, which is 2. As you can clearly see immediately, that 3 times 2 is already 6. So this quantity is not going to be less than or equal to 6. It is not going to be less than or equal to 3. That particular point right here, this point right here, as you can clearly see, does not fall in our region. All the others do. But any points that falls, that tiny triangle right there, do not fall in the region, which is why we cannot tell for sure. I'll give you one more example. So that was the first one. As you can see, that point right here, which is I'm going to put down the coordinates so you can see it. It was 2/3, x was equal to 2/3, and y is equal to 2. That point right there doesn't fall in the region. I'm going to show you one more example. That's it. We're done with it. Again, I need the room. Oh, I forgot my tea. So I cannot take a sip. I'll give you 5 seconds to actually take this thing in case you need to pause it. All right. Let's look at one more. I'm just going to show you one more example, one more point. The first constraint is that 3r plus 2s has to equal 6. So we can't just take any old point. We have to take a point which obeys this constraint and that constraint. That's statement 1 and statement 2. Let's take a look here. How about 3 times 1? 3 times 1 is 3, which means somehow we have to make the second guy 3. How do I make it 3? By getting rid of the 2, by dividing by 3. There you go. 3 times 1 is 3, and 2 times 3 halves, the 2's are going to cancel out, and 3 plus 3 is 6, you see? And again, x coordinate is 1, which is less than 3, and y coordinate is 3 halves, which is less than 2. Again, it follows those two. What is it going to be? 1 and 3 halves. 1, right here, 1, and 3 halves, it's going to be, look, it's going to be 3 halves. 1 and 2, it's going to be somewhere here, in that triangle right here. Right tiny somewhere here. Let's see what happens. Our constraint is 2x plus 3y has to be less than or equal to 6. So when you put in 2 times 1, so this point that I just showed here had a x coordinate of 1 and y coordinate of 3 halves. Plus 3 times 3 halves. 3 times 3 halves. 3 times 3 is 9. Half of 9 is 4.5. This is 4.5, and this is 2. 2 plus 4.5 is not less than or equal to 6. 2 plus 4.5 is actually 6.5. That point lies outside the region. That tiny bloody triangle right there is what is causing us the nightmare. Which is exactly why we still cannot tell for sure if a given point, if a point taken at random that obeys these two constraints, does that lie in that region? The answer is no, because of that triangle right there. That's all there was. That's all it was. I hope you had fun with it, and I'll see you tomorrow, okay? Bye now.